Alright students, welcome to video 5, which is all about one-way analysis of variance, also known as ANOVA. So this is when we're comparing 3 or more groups on 3 or more means, where each of those groups has its own mean. So our independent variable is going to be categorical. So it's going to either be nominal, or we're going to use the responses for an ordinal variable simply as groups. And we're trying to see if there's differences in those groups on their means. So our dependent variable is going to be quantitative, where we have a mean and standard deviation. So for example, if we want to see what students carried in terms of a weapon, did they carry nothing? Did they carry a blunt object, a sharp object, something flammable, pepper spray, or something else? So we want to see, is there a difference in what students carried and the number of zombies that they encountered? So, step 1 and step 2, stating the null and alternative hypotheses. Simply for step 1, we're simply saying that there are no differences between the groups on whatever our dependent variable is. So in this case, there is no difference between weapons used by students on the number of zombies they encountered. Step 2, the alternative hypothesis, well, this is going to be similar to what we see and what we do when we do chi-square with multiple groups. Because we have 3 or more groups, in this case we have 6 different groups, 6 different weapons, 6 different groups of students that use different weapons, we want to see, is there a difference in these groups on the number of zombies they encounter? And because we have more than one group, in fact we have 6 groups, we're going to reject the null and accept the alternative if at least one of these groups differ from at least one other group, which is why we write out our alternative hypothesis such that at least one group is different from at least one other group on your DV. So at least one weapon used by students is different from at least one other weapon used on the number of zombies students encountered. Again, we reject the null hypothesis if at least one group stands out from the others. We don't need all 6 groups to differ from each other. We just need 2 of them, at minimum, to be significantly different in order for us to reject the null. So let's go ahead and move on to step 3, where we're going to actually get our F statistic, which is for ANOVA. Okay, so we're going to go to Analyze, Compare Means. Now we're going to go one-way ANOVA. And we see it has F-test. Let's open up this big, just a little bit bigger. And we'll go ahead and toggle this, like it this way. It makes it easier for me to see. Okay, so we have dependent list and we have factor. So what do you think is going to go under dependent list? Is it going to be our independent variable or our dependent variable? Well, that's kind of a little bit of a clue there. The dependent list is essentially going to be our dependent variable. So in this case, what's our dependent variable? The number of zombies encountered. And then our independent variable by default is then going to be our factor. So we want to see if there's a difference between the weapon of choice and the number of zombies encountered. So we've identified our dependent variable and our independent variable. Let's go ahead and do a couple other things. We want to go to post hoc, and we'll talk about what post hoc means, and we talk about ANOVA in a few weeks. And we want to choose Tukey's test under equal variance is assumed. Tukey's test. This is going to be our post hoc analysis. I want to bring your attention to one thing here, which is significance level, 0.05. By default, we see our alpha level is set at 0.05. Go to click on continue, then let's click on options because we want some descriptive statistics, so that way we can talk about our groups. So we've identified our dependent, independent variables. We've chosen our Tukey's post hoc analysis test, and then we've done our descriptive statistics. Now we can choose OK. So in our output window, we are now going to get four different tables. We see one-way ANOVA, then we have our descriptive statistics table. If we did not select descriptives in our last option, we would not get this table. So we have to make sure that we select that option so that we can actually talk about our independent and dependent variables. And there are our four tables, so let's look at each of these tables in a little bit more detail. So again, we have our descriptive statistics, and so our independent variable is going to be broken down into all of our different groups. That's what each of these rows are, right? We see nothing, a blunt object, sharp object, something flammable, and so on. And this is based upon the groups of our independent variable. And so how we know what this table is telling us in terms of what our dependent variable is right here at the top of the table, underneath the main heading of our descriptive statistics table. It says, how many zombies have you encountered? We have our sample size, this 4, 5, 2. This is not the number of zombies that students encountered. This is the number of students that chose to carry nothing, that had a blunt object, that carried a sharp object. So we have our total 20 students here. This mean is our dependent variable, is the number of zombies that each of these students encountered. So we see that on average, the 4 students who carried nothing ended up encountering 8 zombies. We see that on average, 5 students who carried a blunt object encountered about 4.8 zombies. And we see those who carried a sharp object encountered on average 12 zombies. So we see there's a clear difference among our groups here. We want to know, is there a significant difference between these 6 groups of students on the number of zombies they encountered? So this whole table just really gives us our descriptive statistics, and you can see here all of those descriptive statistics that SPSS provides. So let's take a look at our ANOVA table, our second table. This is where we get step 3, our test statistic. And what's our test statistic for ANOVA? F. So under the F column, we see 4.164. This is our F test, our test statistic for ANOVA. Then we see to the right of that, SIG, 0.016. This is our p-value. So looking at our p-value, do we accept the null or reject the null? Well, remember, we compare our p-value to our alpha level, which is 0.05, and in this case, our p-value is less than our alpha level, so we're going to reject the null hypothesis and say that, yes, there is a significant difference. But at this point, all we know is that there is a significant difference among these groups here. We don't know which groups actually significantly differ from each other, which is why we had to select post hoc tests. That in the event that we did find a significant difference in our overall ANOVA test, in our F test, which we do see here, we're prepared to look at the individual groups. And what our post hoc test, our Tukey's test, tells us is that it takes each of those 6 groups and compares it to one another. And essentially it does multiple independent samples t-tests, where in this set here, we see that we're comparing those students who carried nothing and comparing them to those who carried a blunt object, those who carried a sharp object, those who carried something flammable, those who carried pepper spray, and those students who carried nothing compared to those who carried something else. And so we're looking at our Tukey's test because it's going to tell us all of our different comparisons. I wanted to draw your attention to the SIG column here. What does the SIG mean? P-value. So if we look at our F test here and our p-value for our overall test, we see that it was significant. So we know that there is going to be some significant differences. What we want to do is, because we see significant differences in our overall test, we want to look for p-values that are less than our alpha level in our Tukey's test. And we want to look down this whole column to see, do we see any p-values that are less than our alpha level, less than 0.05? And that will tell us whether or not those two groups significantly differ from each other. So go ahead and pause the video and see if you can identify any p-values that are less than our alpha level, which that then indicate that those two groups of students that carried different weapons significantly differ from each other. When you identify them, go ahead and play the video again. Okay, so hopefully you took a look at the table here and you see that there are a couple pairs that significantly differ from each other. Particularly, students who carried a sharp object significantly differed from those who carried a blunt object. We see the p-value is 0.030. And we see that students who carried a sharp object also significantly differ from those who carried something flammable, with a p-value of 0.012. There are no other p-values here that differ, but you may have looked at this one, which is essentially the exact same pair down here. Sharp object and a blunt object. Well, this one here is showing us a blunt object and a sharp object. So just like our correlation matrix table that we saw way back ago, there is redundancy in this table. So as much as this table can look overwhelming with a bunch of numbers, there's twice the amount of information that you really need to look at. There's redundancy here. But the point is, you want to look to see if you have a significant F-test in your ANOVA test, which in fact we do. We then look at our Tukey's test to find any p-values that are significant, that are less than our alpha level. The last table, we don't have to worry about. Don't even look at it. Don't even include it in any of your work. You won't ever see it in any questions. So now that we've had step 3, where we got our F-test, which we see in the second table, this is where we're going to determine whether or not we're going to reject or fail to reject the null hypothesis. And again, the first table is just giving us our descriptive statistics. But if we find significant differences, if our ANOVA F-test is significant, we need to then look at Tukey's test. And once we find Tukey's test, we then look to see, again, if there's any differences between particular groups. So step 5, our conclusion. You can see there's a lot to write about. And really, it just depends upon how many groups really significantly differ from each other. So this is how we would state a conclusion for an ANOVA test. There was a significant effect of the weapon students carried on the number of zombies they encountered. F-test 4.164, and we're listing 5 and 14, which we'll see what they are when we learn about ANOVA. We're also listing our p-value, 0.016, and eta squared, 0.5979, which is an effect size, which we'll learn about. Different weapons accounted for 59.79% of the variance in the number of zombies encountered. Sound familiar to the way we interpret coefficient determination and alienation? This is based upon our eta squared. And then lastly, because we had significant differences, and then we found a significant effect of weapon on the number of zombies encountered, post hoc comparisons using Tukey's HESC test indicated that the mean number of zombies encountered for students who carried a sharp object was significantly different than students who carried a blunt object or something flammable. However, students who carried nothing did not differ on the number of zombies they encountered compared to students who carried any type of weapon. So, really, if you think about this, students who carried a sharp object who probably thought they would be able to defend themselves ended up encountering more zombies. And on top of that, if you thought that you carried nothing for self-defense, that you probably increase your chance of being killed or being infected. Well, in fact, we don't see significant differences between students who carried nothing and any other type of weapon, so you might as well not carry anything and run and hide. And if you're a guy, be prepared to encounter more zombies. So just to summarize our ANOVA F-test. Really, the first box is going to tell you your descriptive statistics. Your ANOVA second table is really going to tell you whether or not you're going to reject or fail to reject the null hypothesis, step 4. You'll also get your F-test itself, which is step 3, and then you can use Tukey's test if you end up rejecting the null hypothesis to really figure out where the group differences lie. You're going to go under Analyze, Compare Means, ANOVA. Make sure you select your post hoc analysis and your options for descriptive statistics. So always report your independent and dependent variable, your F-test, your degrees of freedom, your p-value, and your effect size. And if significant, report your effect size interpretation and your post hoc analyses describing which groups significantly differ and don't differ. Alright, so we're almost there. One more video to watch, which is all about correlation coefficient.